Okay, let's look at problems 15 through 25. All right, first of all, number 15, notice what it says. It says factor if possible. Now remember, anytime you have a binomial and you see these perfect squares, remember what you're automatically going to try to do. You're automatically going to go into reverse FOIL mode and you're going to think about, okay, well, if first times first gives me 4x squared, then the first term has to be a 2x and a 2x, all right? And then if we think about what would multiply to give negative 81, well, that would have to be a positive 9 and a negative 9. Now remember what we talked about in class, all right? We said that when you FOIL this out, we have no outer and inner term. They canceled each other out. So that's why we need the same numbers and we need opposite signs. So that's how the first one works in 15. Number 16 works the same way. So x times x gives you x squared. What multiplies to give negative 49, positive 7, and negative 7. And then number 17 works the same way. All right, number 18 says factor out the GCF, then factor the remaining polynomial into two binomials. So if I look at 18, I can see that I'm going to factor out a 5s squared. All right, so looking at number 18, the first thing we have to do is to factor out the GCF. So I'm going to take out a 5 and an s squared. Now remember what happens is it's telling us here if we have anything else left inside, we have to try to break it down further. Notice I still have a squared term, so that's a good indication that I'm going to need to break this down further. So once I pull out the 5s squared, I'm going to break the s squared minus 25 into s plus 5 and s minus 5. Now that is a complete answer. All right, looking at number 19, I factored out an x squared. I did try to factor out, tried to do master products with what was left, and when I tried to work it out, I could not find a master product that multiplied to give negative 30, but added up to give a negative 5. So that told me that what was left could not be factored any further, so the only thing I could do there was factor out the GCF. All right, number 20 deals with factor by grouping. Remember when we learned this, we grouped the first two terms, we factored out the GCF, in this case 2x. Then we grouped the second two terms, and we factored out, again, the GCF. So it's kind of like doing boxes. You could put this in boxes and do it that way. And the GCF in the second one is 9. So we have our two matching factors. So I have 6x plus 5 as one factor and 2x plus 9 as the other one. So this would be how you would factor this by grouping. For number 21, we're going to do the same thing. We're going to group the first two, factor out an x, group the second two, factor out an 8, and that's going to give us a common factor of 8x minus 9. So that goes into our one group. And then what's left would be x plus 8, factor by grouping. All right, now when we get down to number 9, we have reached the kinds of problems that ask us to solve. And we even have the directions on here. Solve it and use the zero product property. So, taking a look at the first one, I have already got this factored, and there's already a 0 on one side. So I'm going to immediately set each factor to 0 because I'm trying to figure out what would make each thing inside parentheses equal to 0. So I'm going to solve this for x. So 4x equals 7. Divide by 4, so x would equal 7/4. So that's one of our zeros. The other 0, I'm going to do the same thing. I'm going to subtract 5. I'm going to have x equals negative 5. All right, number 23, we're going to factor out an a. Actually, this is incorrect. Should have factored out a 2a. And let me fix this. There's a wrong mistake here on my key. So the good part about factoring and finding zeros is that even if you don't factor it correctly, sometimes you can still get the correct answer. Without factoring completely, I should say. So if I factor out a 2a, that is going to give me an a plus 13 left inside. All right, and now I'm going to set each factor to 0. So I'm going to set 2a equal to 0, divide by 2. So a would equal 0. That's one of our zeros. To get my other 0, I'm going to take a plus 13, and I'm going to set it equal to 0. I'm going to solve for a, and so a would equal negative 13. So that is my other 0. All right, going down to number 24, I did this again, the master product here, because we're dealing with a leading coefficient that's not 1. And you can see my two factors. I did this one by grouping. You could also do it by boxes. In number 25, remember we have to have all the terms on the left side, or one side, and we have to have 0 on the other. So once I got that over to the other side, I subtracted an 11x. Remember when you do that, you want to write it in standard form. So now that I have that subtracted, I'm going, excuse me, the minus 11x, I'm going to try to factor. This one's should be an easy one to factor, and then you come up with your zeros.